Next, we'll be talking about radicals. We use radicals for a few things. In algebraic operations, we can use a radical to reduce a power. So we know that if we're trying to solve an equation and we have x squared equals 9, then we know we can root both sides. We can impose this root or radical on both sides, and that allows us to square root x squared, which of course allows us to solve for x, and root 9 gives us plus or minus 3. So we use radicals operationally. We can also use radicals when we solve equations. We can use a radical to leave an answer in exact form. And same idea here, if I have x squared equals 10, if I root both sides, if I root the left side, root the right side, square root of x squared obviously is x. The square root of 10, I'm going to leave it as plus or minus root 10. That's the exact form. I'm going to leave it like that. I'm not going to go into decimals. That's the exact answer. Now there's an interesting property we're going to use with radicals I want to show you. So we know that, a couple things here. We know that the square root of 36 is 6. That's easy. Now what I'm going to do is I'm going to rewrite 36 as 4 times 9, which it is. 4 times 9 is 36. So I'm going to write this. I'm going to say the root of 36 is the same thing as the root of 4 times 9, because 4 times 9 is 36. So that's okay for us to write. Now the question is, wouldn't it be nice if I had root 36, if I could break up this root and just root the 4 individually and root the 9 individually? Does that work? Is that true? Because if it is, it's going to help us reduce some radicals. Well, let's take a look. I know root 36, okay? I know the square root of 4 is 2. I know the square root of 9 is 3. And obviously I know 2 times 3 is 6. And root 36 is 6. So the good news is that yes, that property does work. So we're going to use that. And this is what it looks like up here. If you want to make a note of this or put a box around it or something. If you have the root of AB, something times something, you're allowed to root each one individually. That's going to help us. So we're going to do a process called, reduce a radical. So to reduce a radical, what we need to do is find two numbers that multiply to 20, and our idea is to pick one that has an integer square root. So for example, suppose I'm asking to find the square root of 20. I know I can write the root of 20 as, well, root 1 times root 20. That doesn't help us. I could write it as root 10 times root 2. That doesn't help us. Or I could write it as root 4 times root 5. That does help us because root 4 has a root, has a square root that we can find. So I'm going to rewrite root 20 as root 4 times root 5. And then I'm going to take the square root of 4, which is 2. And this ends up being my final exact answer. 2 root 5 is the same thing as root 20. If you go in your calculator, if you go root 20 on your calculator, or 2 times root 5, you get the same answer. So really what we're doing, it's kind of like when we had fractions. Remember if we had a fraction, 5 divided by 10, we would rewrite that in a lower form, 1 divided by 2. They're both equal, they're both the same thing. It's the same idea here. We're just trying to take something, I guess, a little bit larger and write it in a smaller or simpler version. Okay, suppose you had root 50, which I should have written there. Suppose you have root 50. Well, root 50 is equal to root 10 times root 5, which doesn't help us at all. I don't know the square root of 10, and I don't know the square root of 5. Doesn't help me. But I know root 50 can be written as root 25 times root 2. And this does help us, because root 25 is 5. I can take the square root of 25, which is 5. So this ends up being 5 root 2. This is 5 times root 2. Don't be thrown by this notation. We've written things like this all the time. 5 written beside root 2 means 5 times root 2. Just like if I had, 5x, that means 5 times x. Okay, we write things side by side all the time. This is okay. Now, kind of like fractions, to add or subtract radicals, we need a common root. So here, if I have 2 root 5 plus 4 root 5, well, it's simply 6 root 5. 2 apples plus 4 apples, 6 apples. We're allowed to write it like that. In this case here, suppose I had 5 root 3 plus root 48. Okay, these are not like radicals. So what I would do is I'd look over at the 48 and I'd say, well, can I rewrite 48? Well, 48 is 16 times 3. Do I know the square root of 16? Yes, I do. It's 4. There's my root 3. Now this question is obviously rigged. So you have a root 3 and a root 3. So now 5 root 3 plus 4 root 3 is 9 root 3. And that's the simplified version of this. For multiplying radicals, we're allowed to, just same algebraically, we deal kind of with the coefficients out front, and then we deal with the radicals inside. Just like we've dealt with this before. We've done 2x times 5x, right? We've multiplied these things before. We multiply the numbers and then multiply the letters. Same idea here. So if I have 2 root 3 times 5 root 2, I'm going to go 2 times 5 first, which is my 10. And then I'm going to do root 3 times root 2, which is root 6. And then I'm just going to leave it written as 10 root 6. Now, it can get a little complicated. So if we want to FOIL something, FOIL two binomials, we would go through the same process. FOIL is first. So I would have 4 times my root 10, which is here. And then I'd do the outside. So I'd have 4 times root 5, which is here. And then I'd have my inside, 3 root 2 times root 10, which is here. And then I'd have my last, 3 root 5 times root 5 down here. So once you're at this stage, yeah, you have some operations to do. You have some multiplications to do. We break down the root 20, 4 root 5, look for our common roots, and we end up down here. Take a second and try this one. Okay, the answer, the same thing. We're going to FOIL this out first, outside, inside, last. There's some operations there for you to track, and then you should get 18. An interesting question, determine the length of the hypotenuse. I'm going to use Pythagorean theorem. I know the hypotenuse squared, c squared, is 4 squared plus 6 squared. So I operate away. I have c squared is 52. C would be the root of 52. I'm going to leave it like that, root 52. I'm going to try to find some numbers that multiply to 52. Okay, it works out, 4 and 13. I know the root of 4 is 2. So the length of the hypotenuse would be 2 root 13. That's it.